Okay, now we're going to talk about the angles of circles, okay? Interior, exterior, as well as some inscribed and interior angles, okay? So these are inscribed angles that we have right here. Inscribed angles. Inscribed angles are angles whose vertex lies on the circle, okay? All these have inscribed angles. They're formed by two chords. Some cases the chord might be a diameter, okay, or not. And also, an inscribed angle is formed with a chord and a tangent, okay? So there's two types of inscribed angles, but they have the same formula, okay? The measure of the inscribed angle is half the measure of the arc. Half the measure of the arc. As we say here, the measure of ABC is 1/2 of arc AC. So let's measure this angle ABC and confirm that, okay? Measure that angle, okay? Measure the angle at B. The angle there can be measured easily enough. Come and bring it over here. Okay, and we'll measure the arc. Well, of course, we have to, in order to measure the arc, we first have got to create the arc. So here we select it, construct the arc, okay, construct the arc through those and measure it, okay, the arc angle, and surely enough, we should see that that is actually this angle is half the arc at all times, okay? And regardless, if I swing this around, I make a larger arc and make a larger angle. Same thing's going to hold over here with the inscribed angle. Measure this, measure that arc. We need to construct that arc first, and then we measure that arc, okay? And the measure of that arc and angle is going to be exactly twice the measure of this angle that's formed by the chord and the tangent. So here we go with that, okay? And to validate that, we could say we can calculate measure number, calculate the ratio of the arc divided by the angle should be 2 at all times, okay? So there you have it, okay? If this becomes a right angle and it's a semicircle that it intercepts, okay? The interior angle is the angle here at C. Okay, it again is made up of two chords. The interior angle intercepts two arcs, okay? We have to look at the interiors as pairs. Interiors come as pairs. They have the pairs of vertical angles. So, okay, if we take the measure of the angle here, so measure that angle, okay? Measure the angle and get the measurement on that, and we have that roughly 45 degrees. Now what it's saying here is that if we construct the arc that that angle opens out to, okay, construct that arc, okay, measure that arc, we'll put that over here, measure the other arc that it opens out to, okay, construct that arc, construct the arc through there, okay, and measure that arc, and measure that arc. And now, if we take this formula says here, the measure of the angle ACB is 1/2 the measure of those two arcs, the arc AB, which is measured up here, and the arc DG, which is measured right here. Okay, so let's verify that. Okay, so now we go to number, we're going to calculate. Okay, we're going to say, okay, take 1/2, 0.5 of the sum of this arc plus the other arc, okay? See what it equals? It will always equal that angle. Move it around, okay? Larger arc over here, but, okay, the measure of this angle involves these two arcs, add it, and then cut in half. So there's your formula there. Interior angle is 1/2 the sum of the two arcs. 1/2 the sum of the two arcs. Now, for exterior angles, there's three types of exterior angles. Obviously, exterior implying that the points are outside. Okay? The exterior angle is the vertex point is outside. the exterior angle will always meet up with two arcs, the one closest and the one furthest away. Here's another exterior angle. Okay, the angle vertex is outside the circle. It meets up with two arcs, the closest one and the closest one BFD and the furthest one AED. All right. Same thing over here. An exterior angle, vertex is outside. All right. Measures up with two arcs. Measures the sides of the angle, sweeps out, okay, and crosses to create two arcs. The furthest one, ABC, and the closest one. Every one of these, okay, the measure of that angle is half the difference of the furthest arc minus the closest arc. Half the difference of the furthest arc minus the closest arc. The only difference is the way those angles are formed, okay? So here's an angle formed with two secants. Two secants are what? Lines that cut through the circle at 2 points, okay? The formula says the measure of the exterior angle is 1/2 the difference of the arcs, the furthest arc minus the closest arc, okay? So let's just confirm that. Let's construct and measure this arc. Construct and measure that arc. We get a measurement for that, okay? Construct and measure the arc BGD. Okay, measure the arc, or let's say construct the arc first, then measure it. Measure the arc, okay? And the formula says take these two, subtract them, and cut it in half. That will be the measure of angle C. Well, let's do that by let's do that formula first. So it's going to be, we're going to say it's 1/2, 0.5, okay, times the difference, the largest one minus the smallest one, okay? And let's see, that gives me this value of 2649. Now let's measure this angle C, and hopefully, and it will be guaranteed, that that angle will be, okay, that same value. Okay, bingo, there it is. Okay, so the angle there is, okay, the furthest arc minus the closest arc, their difference cut in half. There's the formula. Okay, furthest arc minus closest arc cut in half. Always be the case. Change the angle here, fine, it's going to happen. Okay, now notice, and this is going to be the other two cases. Here I swing this around so that this becomes a tangent now. Okay, it becomes a tangent, only touching at 1 point. Still, okay, it's the arc AFD minus the arc, okay, BGD. The furthest arc minus the closest arc, the angle cut in half, okay, all right, that will give me, that's the relationship there. Same thing over here. Here is the exterior angle formed with one secant and one tangent. So again, this point D is the point of tangency. It's only touching at 1 point. Okay, we measure the arc through AED, measure that arc, construct that arc first. Okay, measure that arc. Okay, and take the measurement, construct the arc BFD, that's the closest arc, construct the arc through there, measure it, measure it, got something selected there, okay, select that arc again, measure it, okay, and let's take their difference and cut it in half. That should give me this measure of angle C. All right, so calculate, calculate half the difference, 0.5 times 0.5 times, okay, the furthest arc minus the closest arc will give me the measure of that angle. Let's see, let's find the measure of that angle. Should be exactly that. All right, let's check it out. The angle there at C, that's okay, a little hard to grab, okay, so we're going to have to be a little, okay, got it. Measure that angle, that angle, there it is, the same thing, same thing. So again, that angle, half, there's the formula right there. Half the furthest arc minus the closest arc, okay? And lastly, same, exterior angle, same difference, same difference. This is easier though, okay? Because really, if you know what the arc, let's say here's the one arc. Measure that arc, okay? Let's measure that arc. Okay, let's select that arc. And let's measure that arc, okay? That arc is measured. Let's get that to a little, it's 130. Let's make it 130, as close as we can get. 130, okay. Now, you don't need the larger arc, A, B, C, because the larger arc is the rest of the circle, okay? So if this smaller arc right here is 130 degrees, then the larger is 360 minus 130, which makes that 230. So it's actually 230 minus, okay, 130, which is 230 minus 130 is 100. Cut in half is 50. So we should find this angle up here. The measure of that angle should be right there, 50 degrees. There it is, okay? So with the case of the exterior angle with two tangents, okay, with two tangents, you only need one angle. You give you one arc. We give you the arc. The other arc is the rest of the circle, okay? Not that difficult. The same formula for the three different types of exterior angles. The measure of the exterior angle is 1/2 the difference of the large arc minus the small arc. 1/2 the difference of the large arc minus the small arc. There you have it, okay? That should do you, and hopefully you have a better understanding of the angles belonging to circles.